All right, everybody. This is it. This is the thing you've been waiting for with bated breath. Not really, but this is sort of the last thing that I have to present to you guys. All the lectures are done, and I'm going to post some tips on what to do and what not to do for the final paper. But um, as you guys are working on your first submissions, um, keep in mind that I asked you guys to say we had 80 people total, 20 per group, just to give it some nice numbers, and that I would put the numbers together for you to make a data set. Now, the one thing that was trickiest for me is obviously making numbers that would fit for anything you want, but you can label them any way that you want. So I just wanted to show you guys what I did, where the printout is, and give you a copy of it, so that you could do what you did with the fill in the blanks results section assignment, and you can use that to fill in your own scores and blanks for this data set. Now, the only thing that's different, of course, is that you have different variables that you've switched it to. Some of you guys have gender instead of priming condition. Some of you guys went in a different direction altogether. And the trickiest part, I think, for me, whether you guys realize it or not, one of the ways that you described in your proposals for the dependent variable was cheating as opposed to creativity, which is really what the DV showed. So for those that wanted to change their DV from a number that measured creativity to something that measured maybe likelihood of cheating or something like that, I wanted to make a data set that could potentially fill both of those things, and give you one little tip when you're writing, if that is your dependent variable. Because remember, in your first submission, you have to properly operationally define these things. That's what I asked for in the proposal. Not everybody did that, but that's okay, because really you can make up for it by making sure you have it in your method section. So really quickly, here we see row 1, column 2. Down here we see row 2, column 1, column 2. So this is basically just the numbers that I put in. And I put in the numbers. This would be hypothetically, if you're keeping the same dependent variable, the rat test would be a measure of creativity. Now, of course, there could be a number of different questions on here, but in order to keep the data the same, whether you wanted to do the rat test DV to measure creativity, or whether you wanted to do something like a likelihood of cheating, the maximum score on here I put is a 10, as you can see over here, 10, 10, 10, 10, right? And the minimum score I put was a 2, although I could have probably put 1s. In this way, there's no zeros, there's nothing above 10. So if you wanted to do a regular rat test, then you would just give it as a ratio scale of measurement, and it was a score, to 10. If you're doing likelihood of cheating, you can still use that as a DV. And whether it's a scale of 1 to 10, however you do it, the likelihood that the person will cheat, then you can still use a 1 to 10 scale. The scale of measurement would just be interval and not ratio, right? So that's the only difference here, and the fact that you have to label it. So just looking at this, what we see is numbers here for one group, numbers here for the next group, numbers here for this group, and numbers here for this group. And what that translates to is what we see here. So you can see there's a lot of different information in the boxes. The only thing that I kept when I transferred it over and copied it over is the number of people per group. So you see 20, 20, 20, and 20. Again, looking at these scores, we have things like variance, mean, standard deviation, standard error. The only thing I kept was the number per group and the actual mean. So the means here, 8.6, 7.25. Looking here, 7.925 is the marginal mean for this one. For row 2, we have 20 per group. We have 7.4 and 3.8. respectively, with a marginal mean of 5.6. Going down, marginal means of 8 and 5.52. And then this is going to give us our summary table here. Right, so what we see is the biggest difference that we see here that I must remind you guys, so please pay attention to this carefully, is we did a within subjects design or within groups design for the first fill in the blank. So each of the row and column, each one, item type and type of processing, had their own error. In a between subject, this actually makes it a little easier for you. In a between subjects design, the error term is the same for everybody. So in this case, the only thing we had to worry about was, degrees of freedom. So for each of these rows, whatever your first IV is, degrees of freedom is 1 in 76. Your mean square, your F value for the first one is 43.58. Your mean square error here is going to be the same as 2.48, and the 76 degrees of freedom is going to be the same one for each of the main effects and the interaction. So remember how in the fill in the blank we did F of the 2 degrees of freedom, which will always be 1 in 76. In the last one it was 1 in 9. And it was equals, and the F equals, here's the F value, and then the MSE, right? MSE is going to be 2.48 for all of them. For IV1, it's going to be F of 1 in 76 equals 43.58. Mean square error equals 2.48. P-value less than 0.01 or less than 0.05, whatever you feel comfortable with. For the next one, this is the columns. So this is IV2. It's going to be 1 in 76, 49.38. Mean square error again, 2.48. Your p-value is less than 0.01 or 0.05. For the interaction, we have 1 in 76. Your F value is 10.21. Your mean square error is again 2.48. It's always going to be the same number in a between subjects design. And your p-value again is less than 0.01. So what we got is significant values across the board. The only thing that you have to figure out, so let me go to the actual document that I gave you. Here's the summary table. So here's IV1 level 1, IV1 level 2, IV2 level 1, IV2 level 2. Here's your marginal mean for level 1 IV1, marginal mean for level 1 IV2. Your marginal mean here, 8 for IV2 level 1 and IV2 level 2. So the only thing that I put here that's relevant is the number per group, which doesn't matter really. Everybody knows 20 per group. So for level 1, 40 people, and 40 people did level 2. For this level 1, 40 people did it. This level 2, 40 people did it. 20 per group, right? Like I told you to say. Here's your cell means: 8.6, 7.25, 7.4, and 3.8. Those are the ones that you are graphing. The only differences that you have here is that what you label them. So if I were to go back to, and I forget where it is, I think it's under here. If I go back to this Excel sheet that I used to show you guys how to graph in Excel the other day, I just put the numbers in: 8.6, 7.25, 7.4, 3.8. So if I'm making the graph with these numbers, and here I've put them in for you, right? So you just have to go and copy this. All 9 cells are highlighted. Again, we go to insert. We can go to column. To line graph. First one, boom. And here is our graph, right? So one of the things we want to do is go to chart tools, chart. We want to get rid of the grid lines. So here's the horizontal grid lines. We want none. And boom, it's gone. The other thing that I didn't show you the other day is, if you can, to click on the actual data labels, or not data labels, but the actual data itself. There should be a way that you could click on it and be able to change these individually, change these colors from red and blue to either dashed and dotted, or again, we can switch column and rows if you really want to, right? I just clicked on that and it should probably do it in a second. But Doesn't really matter which one. Of course, with the axis, with the labels, right? Legend, we want this at the right. So you're going to have it over here. Everything else is good. You want to label your x-axis, label your y-axis. And when you're labeling these levels, right, one of the things that, and you can see that that both of these groups decline, right, as you go from IV level 1 to IV2 level 2. But the red line, right, decreases more. So that's where your interaction is. They're both decreasing, but it's not a parallel line. So you see the interaction here. So make sure that you're able to discuss that. So if for most people, right, if I were to do this again, we could just do, go down here instead of level 1 IV1. Remember we had the two opaque versus transparent. So if we did that, opaque, right, oops, transparent, and we were to go over here, a lot of people decided to change it to what I suggested, which was gender. So you can say male and female, or female and male, either way. And if you did this, 8.6, 7.25, 7.4, 3.8, right? So if I were to get rid of this, let's just cut. And then I were just to use this one with the actual labels. So now we have the two. We kept the same transparent and opaque, which was cheating condition. And instead of using priming, we used gender. So if we were to do that again, go to insert, go to line, here we go. And then you'd get the same thing, but now it says opaque and transparent, and it says male and female. So again, with the legend, we'd put it at the right. Again, with the grid lines for horizontal, we put none. So we're off to a good start. Data labels. Looking at changing the, right, if we were to put change line color. How do we do that? Edit chart title, edit axis title, change to line chart. Get help on changing. So we should be able to somehow, normally before, and I haven't used the 365 version, or maybe it's my Chromebook, but you're able to normally click on the line and it'll light up, and you can select to change the type. So you can make it a dotted line, a broken line instead of a solid line, and just remember that it has to be in black and white. And whenever you change it here, it's going to change on the legend automatically. So really, you're just looking at changing your label. So maybe you you decided you didn't want, you changed gender, but instead you changed gender from cheating condition. So maybe you have primed condition. So maybe you have primed and maybe not primed or something like that. You do that, hit enter, then boom, it automatically changes here. So however you labeled it, right? So the nice thing, again, if we were to go to chart tools, and I were to go to like axis titles, if I went to the vertical axis, that would be your Y. Remember, we wanted rotated title. So here, the title text, if you wanted it to be RAT score, right, you could just hit rat score, and boom, right here becomes rat score. You've labeled it. But let's just say that again, rat score is not what you wanted. You decided that you like it better to know likelihood of cheating, and that's on a scale of 1 to 10, right? That's why this is where we got this. You can use the same scale. You wouldn't have a 0, of course, but there's nothing at 0. So let's say it's you decided to show it as the likelihood of cheating. Again, you can go to primary vertical. We can go to rotated title. As soon as we get there, where are you? Right, vertical, rotated title. Maybe it's not going to let me do it now. But usually it's probably easier on yours. Instead of rat score, you would just type in likelihood of cheating, and it would go same thing across here. So that's how you make your graph. Just remember that we need a title on the top. We need an x-axis title. We need a y-axis labeled. when you copy and paste this into a Word document for your last page, we want the page number on it. You don't need a label other than on top of it. Up here, it would say figure 1. And on the bottom is the figure caption, which would say figure 1 in italics, and then give me the 1 or 2 sentences on what it is. So that would be your graph for the results section. When you're actually writing your results section, as I said, so here's the numbers that you graphed. Going down, whoops. You can see here's the table that I gave you on the same page. So again, sum of squares doesn't matter for you, but whatever IV1 was, if that's gender, if that's cheating condition, if that's priming condition, whatever it is, your degrees of freedom are 1 in 76. F value is 43.58. Mean square error 2.48 for all of them. It's the same mean square error. In a within subject design, each term has its own error. In a between subjects or independent design, which is what you guys are proposing basically, then your mean square error is going to be the same for each one. 2.48. F value for IV1, if that's gender, if that's whatever it is, it doesn't matter because they're all significant, right? So this is very much like your fill in the blanks, which is why that's such an important, why it's such an important assignment, because you can just basically use that fill in the blank sheet to go over what your variables are. So again, if IV1 is cheating, it could be opaque and transparent. A lot of people for IV2 put gender, which just becomes male and female. We see a main effect of cheating condition or priming condition. We see a main effect of gender or whatever you changed it to, and we see an interaction. So just make sure that you have the right numbers in place and that you write which one's higher. If we're looking at the marginal means to figure out which one's higher, again, looking at this, if this is IV1 level 1, if this is opaque, the cheating condition, and this is transparent, right, or primed and not primed, we see that there's a main effect. The direction of the effect is that the cheating condition scored higher on the creativity test, or the ones that cheated scored higher on a likelihood to cheat, if that's what your DV is changed to. So 8.6 is higher than 7.25, higher creativity or higher likelihood of cheating for the cheating group or for the primed group. Here we can say males and females maybe. So males, or maybe this is males and females and this is cheating and not cheating, right? However you label it. 7.4, we see a main effect of IV2, whether that's gender, priming, cheating condition, whatever it is that you changed it to, morality or immorality, whatever it is, right? So those in this level scored a lot higher on the creativity than those in this level. In fact, basically doubled, right? 3.8 to 7.4. Here's your marginal means. This shows you overall that IV1 level 1 scored higher than IV1 level 2. And the same thing here, right? IV2 level 1 scored higher than IV2 level 2. And that tells you where your means are. I told you didn't have to worry about standard deviations. So just use this data set, these numbers, and use the fill in the blank template that we did for the results section before, only using your variables. So instead of saying acoustic versus semantic, it'll be maybe male versus female. Instead of saying words versus drawings, it might be opaque versus transparent, or however you relabeled them. So your graph should be fairly simple to devise. You just have to make it the right way. And you have the numbers here to help you. So hopefully this tutorial gave you everything you need. And at this point, if you have any questions, obviously I have office hours. And good luck on your first submissions. Make sure that you label properly your operational definitions. Make sure that you define them and not just write, opaque versus transparent. Well, what does that mean? Don't write male versus female, even though it's fairly obvious.